Hello, this is Joe. I just wanted to go over a totally awesome project that was turned in by Nick. He had just a slight error, and I just wanted to go over the project. So he did did people quit smoking using a drug or a placebo, and he was given 26 studies, and the QTs were total who quit, TTs were total treated, QC was total who quit without treatment, and TC was total number not treated. Those numbers from the 26 studies, when summed up, gave us a sum of 880, 3140, 514, and 2706. When those were added into a confusion matrix, it looked something like this. And you can see, so drug or placebo are my rows. Did they quit? Yes is column 1, no is column 2. And each cell is labeled as A, B, C, or D. We were given QT, QC, TC, and TT. Since we were given those, we can then figure out the rest of the numbers. Here are the numbers. So these are our observed or actual values, and I got the values using the formulas here. So D was H minus C, 2706 minus 514. A was E minus C, B was G minus A, so on and so forth. And when I filled in my actuals, I had all those numbers. Now what I needed to do to do a chi-squared is do my expected, and I used my expected formula, which is basically to find there is an actual and an expected. So to get what I was expecting, it should have been the ratio of 3140 to 5846 versus an observed number total of 880. That sets up like this. So x over 880 x is to 3140 as 880 is to 5846. My x that came out then was 472.67. I did that for all my expected values: A expected, B expected, C expected, D expected. When I got those numbers, I was able to plug them into my expected, which is the bottom right hand of each cell. Once I had that, I could compare my actual or my observed values to my expected values and get a chi-squared. When I did that, my chi-squareds turned out to be 24.085 plus 4.268, yada, yada, yada. My observed chi-squared was 61.258. My degrees of freedom for this project was 1. So my observed chi-squared was 61.258. When I went to my table, I saw that for a degrees of freedom of 1, and yes, you might typically want to look at a 0.05 critical value, or I'm sorry, p-value, but you want to look at a 0.05 p-value to tell you of significance. But in this case, our observed chi-squared was so high, I actually went to 0.01. In that case, the critical value was 6.6. So if my observed chi-squared value is greater than 6.6, I know that I have something that is significant at a 0.01 level. My 61.258 is definitely bigger than the critical value of 6.635. So we know that we have something significant, and I stated that the null hypothesis would mean that the drug is not effective. So that your null, you typically say there's no difference between groups. Your alt hypothesis typically says that there is a difference between groups, in this case that our drug is effective. And since our calculated chi-squared of 61.258 is well above the threshold p-value of 6.635 for a p-value of 0.01, we can say that there is a significant evidence to reject the null hypothesis. This was one of the best student projects I've had turned in 3460. It was absolutely fantastic, and I commend the student who did it. Well done. Well done.